so far in the last class, whatever we have learned, that is a special type of partial differential equation, which is a linear partial differential equation, but order is nth order. But that partial differential equation is a constant coefficients. Okay. So how to find the particular integral, that is the target for today's learning. How to find particular integral for that means your uh, differential equation, partial differential equation is of the form f d dash z is equal to f of x comma y. So this is your nth order partial differential equation, which is linear, and it is a special type. Why I tell, because the coefficients are particularly constant. I'm not considering coefficients to be functions of x and y. That is not our target initially. Okay. Now, so far, what we have learned, that is how to find complementary function. That means solution of the associated homogeneous differential equation PDE, that is f dt dash z is equal to 0. Right hand side is equal to 0. So in this case, how to find complementary function means how to find solutions, that we have learned it. Clear? Okay, now I like to give one remark that in case of ordinary differential equation, it contains arbitrary constant, but in the case of solution to a partial differential equation, it contains arbitrary functions. But what it makes difference? In the same spirit, while an ordinary differential equation of order n has n linearly independent solutions, a PDE has infinitely many. This is to be noted, infinitely many independent solutions. Why? Because, in case of partial differential equations, general solutions involve arbitrary functions. So since the function is arbitrary, so you can make infinitely many independent solutions. So whatever the solution space for the associated nth order homogeneous linear partial differential equation with constant coefficient, that solution space is will be an infinite dimensional vector space. But in case of ordinary differential equation, say for example, your f only d, this is d is d dx, this is y is equal to 0. Whatever the solution space, if its order is n, then it has exactly n number of independent solutions. That means solution space forms a finite dimensional vector space. But in case of your partial differential equation, whatever associated homogeneous partial differential equation, if you look at the solution space, it will be an infinite dimensional vector space. Clear? Because we can create infinitely many linearly independent solutions for that. Okay, now come back to here, how to find a particular integral in case of partial differential equation. So particular integral, this is basically symbolic operator, and this part 1 by f d dash, this part is a symbolic operator, and this looks like inverse operator of f d dash. What's the meaning? Meaning is that it will be a functions of x and y, another functions of x and y without containing any arbitrary constants or arbitrary function, such that if you operate that function with this differential operator, then it has to give the uh, domain function, means whatever in the domain. Okay. So this is just like operator, it maps from this to this. This is your f d d dash. Okay. And whatever the inverse operator is like this part basically. If I take some different color. Okay, so if I choose this thing, then it will be your inverse operator. So it is we have to find some g such that if you operate um, this function, this operator f d d dash 2g, then you have to get small f. Okay, so that is what your inverse operator. So that function is regarded as your particular integral, pi. In short, we write pi, particular integral. Okay. So if you just try to recall in case of single variable, ordinary differential equation, there are certain rules how to find it for special type of functions. So similarly here also we have to learn certain rules. Okay. Okay, so let us just recall what is the meaning of d square d cube. These will stand for the differentiating partially with respect to x1, d for 1 time differentiate partially with respect to x. D square means twice, d cube means thrice. In this way we have to go on. So what is the meaning of d dash? D dash is basically partially differentiate with respect to y once, and d dash square is partially differentiate with respect to y twice. In this way it goes on. Similarly, 1 by d, what's the meaning? Who can say? 1 by d is basically integrating partially with respect to x once. 1 by d square twice. You have to integrate partially with respect to x. Similarly, 1 by d cube means integrate with respect to x partially. Partially means what? Other variable like y, you have to make it, treat it as constant. Okay. So 1 by d3 means 3 times integration partially with respect to x. Similarly, 1 by d dash, 1 by d dash means 1 time integrating partially with respect to y, keeping x as constant. Its square means twice, its cube means thrice. In this way, it goes on. So these will be necessary. Okay, so depending on the nature of the function, this function, we are having different cases. Okay, so if your function fxy is of the form, means is a function of ax plus by, means maybe say for example 2x minus y, that means what is your a is equal to 2, what is your b is equal to minus 1. Okay, so in that case what we have to do, you see this. we have to replace d by a, d dash by b in f d d dash to get f of ab such that f of ab is not equal to 0. That otherwise we have to apply the special case. I will be coming to that and substitute x plus by is equal to u and integrate your f of u n times with respect to u. That means ultimately, suppose your f of a comma b is non-zero, then you can actually do it. Integration n times. How many times? It is n times, whatever the order of the differential equation, n times fu du. Okay, this is n times. Okay, now come to the special case. Whenever f of ab is equal to 0, then we have to differentiate f d dash with respect to d partially and simultaneously multiply by x. That means first we write x in the left hand side. That means beyond your operator. And this is your operator, symbolic operator. And if we write it here, that means we have to operate. And if we write it in the left side, then its function is over. It is independent of the operator. So x will be coming in the left. And what we do in the denominator, we like to differentiate partially with respect to d, capital D. Differentiate this operator with respect to capital D partially. That means d dash will be treated as constant. And then as usual, whatever your right hand side function, it will be intact, capital F of ax plus by. Sure. Again, it may happen that if you try to put it um, whatever it is coming here, if you try to put d equal to a, d dash equal to b, then it may again come to 0. Then again we have to multiply x in the left hand side, and again we have to differentiate partially with respect to d. So how many times we have to do until uh, f of ab, your f of ab is not equal to 0. It becomes non-vanishing. So up to that we have to make differentiation. For one time differentiation, we have to multiply x once in the left hand side. Similarly, two time differentiation, then we have to multiply x square in this way. Okay, so this case is also taken into consideration. Okay, then come to the second case. Suppose your function not is of the form ax plus by, but it is of the form x to the power maybe x square y cube. So in this case, what we have to do, we have to write 1 by f d dash. Say for example, this is your x square y cube. So we have to just write 1 plus or 1 minus whatever, plus or minus something whole to the power minus 1. And then we have to expand it, and then you have to operate with the function in the right hand side, because it is a polynomial type function in the right hand side part. So it is having finite power, means degree is finite. So naturally, if we try to expand it in terms of the infinite series in the ascending power of d dash, d by d dash, whatever it is coming, so ultimately after certain stage all the terms will be vanished. Then definitely we can do it, we can calculate it. Okay, so that is our target. If we look for the examples, then we will realize it. Okay, so in this case, okay, so this thing, whenever d operated with something, then it means differentiation. D dash operated with something, then it means differentiation with respect to y. differentiation with partial. This is partial. Here it is also partial differentiation with respect to x, like that. 1 by d already I told. This is different integrating with respect to x partially. 1 by d dash its meaning is that integration with respect to y partially. Okay, so these things we have to apply after that. And in sometimes, okay, let us recall what is it. 1 by say for example 1 plus d plus twice d dash square divided by 3 whole to the power minus 1. Okay, so how to here say for example x square y square, then how to do it? Okay, I'll be coming to one note. Okay, I like to give one example, like d square minus d dash z is equal to twice y minus x square. Okay, so this is your one example in this respect. So what is auxiliary equation? First we have to find CF. Z is equal to ZCF plus ZPI. Okay, complementary function first we have to find, and this is your complete integral. Okay, so how to find? We have to put d equal to m and d dash is equal to 1 in the associated homogeneous equation. That means d square minus d dash and z is equal to 0. This is your associated homogeneous equation. So we will get m square minus 1 is equal to 0. That means m is equal to, who can say, plus minus 1. That means complementary function ZCF will be phi1 y plus x, y plus mx plus phi2 y minus x, where phi1 and phi2, these two are arbitrary function. Okay, so complementary function, this part is over. Okay. Next, we like to find 1 by d dash square minus d dash. What is it? If I do minus 1 by d dash common, then what it happens? Then it will be 1 minus d dash square divided by d dash. Clear? This. Okay, so this is 1 by d dash. This means 1 minus d square by d dash whole to the power minus 1. So this part, can you find the expansion? I like to ask Prajata.
Sir, by doing binomial expression, I don't really remember the exact formula, sir. But
Okay,
we,
so I just like to recall anyone else. 1 plus x whole to the power minus 1 or 1 minus x. In case of 1 plus x whole to the power minus 1, its expansion is 1 minus x plus x square plus, sorry, it will be minus x cube. In this way it goes on. Okay, so if it is 1 minus x whole to the power minus 1, all are plus. 1 plus x square plus x cube. In this way it goes on. Clear? Okay. And when what is the rule for convergence? Mod x is less than 1. This converges for mod x less than 1. So how we can get from Bernstein coefficient. Okay, so I can write in general x plus a whole to the power a, not whole to the power n. This is a binomial expansion, all of you know, whenever your n is a positive integer. Okay, so it is having exactly n plus 1 terms. Clear? But if n is your rational number or n is irrational number in general, if your n is any real number, then how you can expand it, that is that can be done by means of Bernstein coefficient. Okay, you know, whenever n is say for example -3, even it is a rational number also -3, then it is having how many terms in the expansion? How many terms will be there? If n is equal to negative, no one can say.
One term.
One.
So infinite, sir.
Infinite. Okay, absolutely correct. Because in that situation, Bernstein coefficient, how it is written? N R. This is the notation. Okay, should I write it in different color? Okay, I have to give. I like to. What it is? Suppose A is any real number, ACR. A is any real number, A belongs to R, and R is greater or equal to 0. This is integer. Okay. So what is this? Is basically A into A minus 1, A minus 2, up to A minus R minus 1 divided by, who can say, R factorial. Clear? Okay. Now, whatever your NCR, this is a special case of this. And this is n factorial by R factorial into n minus R factorial. Clear? This you all know. This is the value, this is NCR where n is positive integer and R is non-negative integer. Is not it? N choose R. R is non-negative integer, n is positive integer. In that case, what is the formula for NCR? N factorial divided by R factorial into n minus R factorial. Okay, so if we look up to n minus R, then the numerator will be n into n minus 1 into n minus 2 into up to n minus R minus means it will be plus 1, and then whatever it is coming n minus R factorial. So n minus R factorial will be cut it out, so it will be, so this is the superior case, and this is a special case of this thing. Okay, now my point is that if A is negative, then definitely it will go your AR. I don't call ACR because out of -1, how can you choose two things? You cannot choose it. Therefore, it is its naming is different. It is not like NCR. It is a Bernstein coefficient, and it has been used in expanding your this thing, uh, whatever this expansion, Clear? So I think you understand. That is why it is having infinitely many terms, because your infinitely many Bernstein coefficients are coming non-negative. Sorry, non-zero. Okay. So if you can recall this one, then you can find you can recall everything, whatever your mm, means, whatever your expansions are there. Next, I will be back to here. So I have to write 1 by minus 1 by d dash 1 minus it will be plus, everything will be plus d square by d dash plus and d to the power 4 by d dash square. Okay, in this way it goes on. Now if I do it, then it is 1 by d dash and then it will be minus d dash d square by d dash square. It is minus d to the power 4 by d dash u. It goes on like this. Okay. Okay. Now back to your question. Pi, Z pi. This will 1 by d dash square minus d dash. And this is operated on twice y minus x square, you see. So it is whatever the terms it is coming, twice y minus x square. Terms are just, you see, minus 1 by d dash minus d square by d dash square minus d to the power 4 by d dash cube. In this way it goes on. Okay. Okay. Now I have to operate this thing with this total thing. Okay. So what's the meaning of 1 by d dash? Sankita?
Integration partially with respect to y.
Yeah. So it will be y, minus y square for this term. There, because y dy, it will be y square by 2. 2 is cut it out. So it will be minus y square. Okay. Now if we integrate, this is minus plus x square y. Clear? X is independent because x is keeping as constant. We have to integrate with respect to y partially. So only integration like this x square here. This is dy. Okay. So x square y. Now this part, this is over. Now we have to do 2 times derivative first. Derivative 2 times with respect to x. So this term will vanishes. This term will give just your, this will be plus. So I can write 1 by d dash square. This time will be, it is 0 and minus. Oh, already I consider minus plus. This is minus. So minus twice. Okay. So if I, and then rest of the parts, it will be 0, because if we differentiate with respect to x partially 4 times, then everything will be 0. So no need to consider this term. So this contribution will be 0. This contribution for twice y, it will be 0. For minus x square, it will be minus 2, because one time differentiation twice x, next time differentiation only minus 2. Okay. So this is minus y square plus x square y. And now we see whatever it is, it will be plus. 2 will be coming out here. We have to integrate 2 times with respect to y. So one time, that means only y. Second time it is y square by 2. Okay, so it will be x square y this. So ultimately, complete solution of the given PDE is Z is equal to ZCF. What it is? Phi1 y plus x plus Phi2 y minus x, and whatever your particular integral x square y it is coming. So this is your where ultimately we have to write where Phi1 and Phi2, these two are arbitrary function. Okay. Okay. So this is over. So regarding this part, I think there is no ambiguity. Okay. Now,
Sir, I did not get one part, sir. Sir, actually, if you go to sir, the fxy over here, sir, what was the formula? Because it was not x to the power m, y to the power n. So why did
yeah,
we
yeah.
use?
Okay. Good question. So I'm coming here. Uh, if we see here, it is not exactly your ax plus by also. Okay. So actually, whenever your right hand side x plus by linear, then also you can do this method. You can apply this method. Then also there is no ambiguity, because this is case to whatever I told, and that is more general case. Okay. Now you see this cannot be entirely your x plus by, because square term is there. Okay, that is why I use this part.
Okay,
even even if it is only twice y, then also we can use that, because twice y is also of the form ax plus by. Anyway, your question is good, so I think you understand it.
yes, sir, yes, sir. Now I got it.
Okay. Okay, now come back to show up to first two parts are over. Okay. Another case, suppose your f of x comma y is any functions of x and y, any functions of x and y, and your this function f, this operator f d dash, this can be expressed as like this way. That means it is reducible. You can reduce this operator as d minus m1 d dash into d minus m2 d dash into, in this way, d minus mn d dash. So in that case, you can write, ultimately it will be coming. So this is again, this is very much parallel to your ordinary differential equations also. Then we have to see one by one. See, first part is 1 by d minus m d dash. What it is, we have to integrate the function f of x comma y. Instead of y, we have to write a minus mx. Then with respect to x, we have to integrate. Then ultimately, this is a single integration, so we have to integrate it. Okay. Similarly, 1 by d plus m into d dash fxy, its meaning is that we have to integrate f of x. Instead of y, we have to write a plus mx. Okay. So where a is equal to y minus mx, that means y is equal to a plus mx. This thing here, y is equal to a minus mx. Okay. And we have to use repeated application, because it is having a n number of terms here. First, we have to operate here. You see, first we have to do using this thing, then we will get another functions of x, and then again we have to do in the second. In this way we have to go on, whatever the operators are there, we have to do the calculation. Okay, so some exercise or examples I can say. We have to find only particular integral because complementary function, this part is already over. Okay, so you see, okay, one bad habit I like to mention, because from my experience I can say that some students prefer to write, say for example, in case of ordinary differential equation, suppose it is d square plus twice d minus say for example 4 minus 4, it should be x, or maybe x sin x, whatever it is. Some students write it here, it is x sin x by this. So instead of writing in the right hand side, they prefer to write here, but this writing has no meaning. It has no meaning. This should be avoided. Clear? So because this is your operator, symbolic inverse operator, f, in this case f d d dash, this is your symbolic operator. It is operated on the function, whatever in the right hand side, this function. Clear? No question? So you should not write in that fashion. It should be 1 by some operator. It is operated on the function which is maybe right hand side totally. If you write something in the left hand side, that means it is beyond your operator's operation. Clear? Okay, you see the writing style here. This is in this way you can write. Okay, so this function can be written as d minus twice d dash into d plus 3 d dash y sin y. So you have to be little bit careful here. I like to do this part only initially. So 1 by d plus some mn into d dash. Okay, so that means we have to put a plus mx. Okay, so a plus 3x, instead of y we have to put a plus 3x, and x will be keeping as it is. Sin x will be sin x. Okay, so dx. We have to integrate with respect to x only here. So if we integrate it, this will be keeping intact, no problem. So this is basically we have to integrate it by parts. So this is your integration. Now you see that I put the value for this thing. Before coming to this operation, I have to put the value of a here. So if I put it, then it will be minus y cos x plus 3 sin x. Okay. Again, we are having two things operated on this 1 by d minus twice d dash. So I have to apply y minus mx, this thing, instead of y, and x will be keeping unchanged. So similarly, this is only 3, sorry, 3 sin x. So there is no y, so no need to put y is equal to a minus mx. Okay, so it is just 3 into sin x. Then we have to integrate with respect to x and put the value for a dash. And this is another thing, a dash is equal to y plus twice x, and we are done. Okay, so I think no problem here. Take your time, you see it. All of you understand?
Sir, 1 second, sir.
Yes. Actually, after integrating, we have to put the value for a, or value for a dash, whatever it is coming. Clear?
Yes, sir. Yes, sir.
Okay. Now I am having one question. In this case, should or can you apply this thing in terms of ascending power of d and d dash or d by d dash or d dash by d, whatever? And then you operate on y sin x. Can you do that? That means, say for example, can you do 1 plus?
No, sir. No, sir.
Sir,
No,
it's not in XPPI and YTPI formats.
yeah, yeah, very good. Because here it is sin x. Sin x, if you integrate with respect to x as many times, then you will not get to 0. Or if you differentiate sin x by, say for several times, it will not come to 0. Clear? So since the function in the right hand side, it is not a polynomial type function. If you try to use in by expanding, then you will not get succeed. Clear? That is why we have to use certain other method. Okay. And there are certain other things. Should I complete today? In the next class, I can discuss. There are certain other, or should I complete one more exercise? Whatever you will tell, I will do that because time is up.
Sir, next class then.
Okay, no problem. So this much for today. So in the next class, I will give some more exercises. I will solve some more exercises and certain other special uh, cases we will discuss so that you are in a position to um, solve as many as possible in this respect.
Sir, will
Okay,
the notes to this be uploaded today only, or will we get it after the next class?
maybe within tomorrow.
Okay, sir. Okay, sir. Thank you, sir.
Okay,
Thank you, sir.
welcome. Let me take the attendance.
Thank you, sir.